Welcome to this webinar on master key topics in number properties. Before I get started, I would like to know whether you can hear me clearly or not. So I'm adding a poll. If you can hear me clearly, please mark yes. Let me add the poll. Yeah. So if you can hear me clearly, please mark yes. And we'll get started. Yes. As soon as I get enough responses. Okay, so I can see most of you are saying that you can hear me. I can see one or two of you are saying no. I would request you to look at your, check your internet connection once, maybe try relogging in, because from my end, I can see it's working fine, and about 90% of you are saying that you can hear me clearly. So let me end the poll and let's get started, guys. Okay. Once again, welcome to this webinar on master key topics in number properties. This is one of the most important topics in the GMAT. I would say most important section, not topic, number properties. The kind of concepts that are tested here are slightly difficult, but once the concepts are clear, like concepts like factors, multiples, it does become easy to solve these questions. So before I get started, let me briefly introduce myself. Those of you who are attending these webinars for the first time, my name is Saqib, and I am the product lead at GMAT Quiz, and I am also the principal architect of the GMAT Quiz Intelligence. So if you have tried a platform, you must have seen that a platform has a lot of intelligence in it. It creates a study plan on its own, and there's a lot of personalization that is also happening on a platform, and I've been actively involved in building that so that we can create the course as personalized as possible for all of you. I've been in this industry for close to 10 years now, and I love teaching quant. Apart from building products and making sure that I'm personalizing the course for you, I've also designed the quant course for GMAT Quiz. I've even taken the GMAT. I have a Q50 in quant, and those of you who are from India, you might be knowing what CAT is. It's like almost an equivalent of GMAT, where I have a 99.98 in quant percentile. Okay, so that's briefly about me. Let's talk about how are we going to conduct this webinar. So this webinar will be conducted in the same way as most of our webinars are conducted. I would jump directly into the main part of this discussion, that is understanding number properties and its various topics. And I would keep about 10 to 15 minutes at the end in case if you have any questions, related to GMAT Quant or GMAT in general, or about GMAT Quiz, please feel free to ask those questions at the end of the webinar. Okay. So with this, let's first of all talk about what will you learn today, what's going to be the structure, and why did we choose this topic. Okay, so let's first of all understand why this topic. Now, as I told you, in GMAT, the concepts like primes, LCM, GCD, and divisibility are quite frequently tested, either directly or indirectly, in a lot of questions. You would easily in number properties, you would easily get 2 to 3 questions based on these 3 topics. Some of the questions obviously are easy; they're direct based, but most of these 700, 650 level questions, they are not so straightforward. So just knowing the formula of or just knowing the properties of primes or LCM, GCD, or divisibility might not be enough for you to solve those difficult questions. So what are we going to cover? So I want to make sure that I try and cover most of the important aspects of these three topics. So what I'm going to do is I would like to start off with the basic definition of primes, factors, multiples, and divisors. And I'm doing this because some of you might be in the in the initial phase of your prep and may have not come across some of these terms. So it makes sense for me to kind of give you a high level understanding of these definitions. Then what I'm going to do is then I'm going to give you certain questions on factors, multiples, and divisors. Obviously, some of the questions would be difficult. Some of the questions would be directly based on the concept definition that I'll be discussing. But then you would be able to see why just knowing, the formula might not be enough or in some cases, and what kind of indirect difficult questions can you get in case of number properties. Okay. Post that, I'm going to talk about total factors. Now, this is another concept related to prime numbers, where you can get various versions of total factors, total even factors, total odd factors. Those kind of questions can come. So I would like to cover some of the questions based on total factors too. Finally, I would discuss briefly about LCM GCD also. The concepts, I'm discussing some of the concepts here in the initial definition, but I'll cover some more out here, and then we are going to do practice questions on LCM GCD. So a little bit of theory, then questions, then another set of questions based on total factors, and finally LCM GCD. So I'll try and ensure that we discuss all the different kind of questions here. Okay. Okay, I can see a few questions in the chat box. People want to know whether this webinar will get recorded or not. Yes, this webinar will definitely get recorded. Don't worry about it. We usually upload these webinars on our YouTube channel. I am sharing the link of that. If you can subscribe to it, and you would get the notification once we upload the webinar. Okay. Okay, Sam is asking how long the webinar session goes. Well, it depends. Most of the time, it runs from 60 to 90 minutes, depending on how you respond. Okay, so I'll be asking you questions, how quickly the discussion goes, depending on that, anywhere between 60 to 90 minutes for the discussion. Okay, after that, there might be a Q&A, and depending on how many questions you'll ask me, the session might get extended for another 15 to 20 minutes. Okay, so I hope that answers your query, Sam. Okay, guys, let's start off with the concepts of primes, factors, and multiples. So the first thing that you should know about prime numbers is that prime numbers are positive integers, okay? And they have exactly two factors. Now, those of you who are not aware of the term factors, you can understand in this way that prime numbers are those numbers that are divisible by 1, okay, and that are divisible by itself. Okay, so what I mean by that is, just one second. What I mean by that is, let's take a few examples. Let's take 2. 2 is the prime number. 2 is divisible by 1, and 2 is divisible by itself. Okay, so no other number divides 2. Similarly, if you take 5, 5 is divisible by 5, 5 is divisible by 1. Okay, that is why we say that prime numbers have exactly two factors. Now, since I'm using the word factors, let's understand what are factors. Okay. Now, if I say that x is a factor of y, okay, if I say x is a factor of y, then that means x will completely divide y. Okay. So in this case, in fact, let's take a bigger number. Let's take 6. Okay. Now, in case of 6, I can say now 3 is a factor of 6. Why can I say this? Because 6 is completely divisible by 3. So a factor divides the number completely. Okay, so if you come across a statement like x is a factor of y, you should be able to infer, since x is a factor, it will completely divide y. Okay, and if you want to write it algebraically, you can write, since x is a factor, it will completely divide y. So y by x is completely divisible. So I would get an integer. And if you want, you can represent this integer by another variable. Okay. So we can write it like this. These are especially important when you are doing 700 plus level questions, because there you might be most of the questions might be based on variables where you have to translate and set up the equations. So it is important for you to understand the definition of a factor. So factor is a number. A factor basically divides the number completely. Okay. Now, another important thing is that factors and divisors, they both mean the same thing. They are used interchangeably. So at certain places, if you see the word divisors, you can just infer that they are talking about factors only. Okay. Now, the another term is multiple. So if I say x is a multiple of y, okay, x is a multiple of y, then that means x can be written as k times y. Now, this might seem confusing, so let's look at an example. I can say now 12 is a multiple of 6, which means the number 12 can be written as 2 times 6. So k times y. Okay. So this is another thing that you should remember. Now, sometimes people do get confused that, hey, when do I use, y by x equal to k, or when do I use x is equal to ky? So I just, kind of remember it in this way. Uh, though it's more intuitive for me now, but if you want to remember it, you can think in this way, that factors are basically numbers which are smaller or equal to the number. So factors are basically smaller. So like a factor of 6 could be 3, factor of 6 could be 2, factor of 6 is 1. Keep in mind, 6 is also a factor of 6. So if I ask you what are the factors of 6, you would say 1, 2, 3, 6. Okay, so notice all of them except 6, they are less. Okay. Now, when it comes to multiples, multiples are always numbers which are greater or equal to the given number. So the multiples of 6 could be 6 itself, it could be 12, it could be 18, it could be 24, and so on. So if you want to just, if you can visualize this diagram and kind of remember this, you would never have a problem setting up the equation. So you'd know, okay, if 12 is a multiple of 6, then I can write it as 6 times 2. If 3 is a factor, that means 6 is divisible by 3. Obviously, it has to be divisible. Okay. So please let me know if this part is clear or not. If this is clear, then I can, move on to the next part. Okay, I have a question in the chat box. How many prime numbers factors can reasonably expect? As I mentioned before, you can expect about 3 questions at least, but there could be indirect applications of these. When I say indirect application, like you could get an algebra question where, which involves prime numbers, the definition of prime numbers. So I'm not counting those, but direct questions, you can definitely at least expect 3 of them. Okay. Now, coming to the another important thing is, as I told you, that you might be given questions which are based on total factors. Now, what do I mean by total factors? Now, in the previous slide, you must have noticed I took the example of 6 and I told you that 1, 2, 3, and 6 are factors of 6, right? By factors, I mean that these 4 numbers would completely divide 6. So for a small number, you can, definitely manually figure it out. But for numbers which are huge, like for example 510, 450, you would not want to manually count the total number of factors. That's like a long tedious process. So what we usually do is we prime factorize the number that is given to us. So if n is a number, then we write it in the prime factorized form. Now, those of you who haven't heard or don't know what prime factorized means, this basically means that if I have a number, say, let me take a bigger number, let's say 24. Okay. Now, what I would do is I would kind of split 24 into its, I'll keep on breaking it till I have numbers which are totally in the form of prime numbers. Okay. So all of these are now in the form of prime numbers. So I can say 24 can basically be written as 2 cube. I'm writing it on the left hand side. 2 to the power 3 times 3 to the power 1. So the main point here is that the number should be written in the form of a prime number to the power something. Okay, so P1, P2, P3, these are all prime numbers and these are the respective powers. Okay, it's very important that you keep in mind that these all need to be prime number. For example, I cannot, this is not in the prime factorized form. You cannot write 24 is 8 to the power 1 times 3 to the power 1 because 8 is not a prime number. Okay, I've seen people make these mistakes. So so I just wanted to make this clear. Now, how does prime factorizing help us? The moment you write it as in the form of prime number to the to its respective power, all you need to do is to find out the total factors. You take these powers, you simply add 1 to it. So if I want to find out the total factors of 24, say, then the power here is 3, so 3 plus 1. The power here is 1, so 1 plus 1, and I would get 4 times 2, which is equal to 8. So I can say the total factors of 24 are 8. Okay. And I can in fact even show you what are the factors, because 8 is still a small number. So this is usually how I do it. I take 24, I break it in the and write it in the form of as a product of 2 integers. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, if I go any further, I would again end up with the same number. So I'll stop here. I won't take these cases. And I would say that the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24, because all these 8 numbers would completely divide 24. Okay, so I hope now you are able to visualize what are factors, and I hope you have understood how to find it. Okay, if this is clear, if this part is clear, can you take about a minute and a half and try to find out the total number of factors of 120? Give it a shot, and you can put in your responses in the chat. Please send me a private chat and not a public one. Okay, once you're done solving this. Keep in mind, you have to first break it down into in its prime factorized form. Okay, and then use the formula. Take the powers, add 1 to it, and multiply it. Okay, good. I have the responses have started pouring in, which is good. So far, I've got 3 different kind of responses: 16, 12, and 20. But most of you are saying 16, which is good. So once again, keep in mind you need to break this down like this. So keep on breaking it down till you end up. So I've written 120 as 12 times 10. Then I broke down 10 into 2 times 5. I broke down 12 into 2 squared times 3. And then finally, I combined all the 2's. And 3's are standalone. So I wrote it like this. After that, obviously, I'll take the powers, add 1 to it. So 3 plus 1, 1 plus 1, 1 plus 1. So I would get 4 into 2, which is equal to 16. Okay. So I hope it's clear to everyone. Those of you made a mistake, ended up marking 20 or 12. I hope now it's clear what the answer would be. Okay, now let's do this question very quickly. I'll give you 30 seconds for this one. This is pretty easy. How many total positive factors does 13 have? Okay, I've already got 2 responses. Good. Okay. Good, very good. Good. So see here in this case also keep in mind, remember that I just discussed a while back that prime numbers, 13 is a prime number. So it is divisible by only 2 numbers, 1 and 13, right? Now, how do I get the same answer using this formula? Since 13 is itself a prime number, I cannot break it any further. So I would write it as 13 to the power 1. Post that, what I'm going to do is I'm simply going to take this, add 1 to it and get the total factors. That's 2. That's all that we can do. Okay, so I hope it's clear how to find the total positive factors. Instead of manually counting them, you can just prime factorize them and get the answer. Obviously, this is like the very basic, easy version of questions. The questions will be more difficult, but this formula and this prime factorized form, if you haven't come across this before, then I would request you to kind of make a note of it in your copy or paper, whatever you're using, because we are going to use this formula a lot. Okay. Now, let's come to the third and the final part of our discussion, LCM and GCD. Now, LCM basically means, those of you are not aware of the definition of the full form, it's known as lowest common multiple. Okay. Now, we just discussed what is a multiple, right? A multiple is basically, so when I say 12 is a multiple of 6, then that means 12 can be written as 6 times 2, right? Another way to kind of visualize or understand this is that when I'm saying 12 is a multiple of 6, can I say the multiple that I have will be divisible by 6 also? Because it's a multiple, so 12 would definitely be divisible by 6, right? So if I have 24, 24 is a multiple of 4, right? So I can say 24 would be completely divisible by 4. Okay, now we are going to kind of use this concept to understand what do I mean by the lowest common multiple. So when I'm looking for a multiple I'm looking for a multiple of these three numbers. Okay, so you have to kind of translate it in your mind and think, okay, I'm looking for a number which is obviously a multiple of these three numbers, and if it's a multiple of these three numbers, then that means this multiple must be divisible by 24. This multiple that I have has to be divisible by 36 also, and the multiple that I have has to be divisible by 80 also, right? Because multiple is completely divisible by that particular number of which it is a multiple. Now, the process of finding, once you understand this, this is again for a conceptual understanding, but if you want to find it out, the process is pretty easy. What you do is the first step is to find out the, just prime factorize each of these numbers. Okay, so you just take 24 and you prime factorize it and write it as 2 cube times 3. You take 36, you prime factorize it and write it as 2 square times 3 square. And you take 80 and you prime factorize it as 2 to the power 4 times 5. Prime factorization done. Now, when you're looking for the multiple, keep in mind that the number should be divisible by each one of these, all these three numbers, whatever the multiple that I'm choosing. Again, I'm reiterating this fact. So obviously, the multiple should have all these prime numbers. Okay, that is why I need to consider each prime number. That's very important. Okay, so I'll be considering 2, 3, and 5 because I want a multiple which is divisible by all these three numbers. Now, if I want the multiple to be divisible by all three, I have to ensure that the powers of this 2, 3, and 5 should be the highest power, right? So I have to take 2 to the power 4 only, 3 square only, and 5 to the power 1. Now, those of you are wondering, hey, why 2 to the power 4? Why not? Why can't I take this? What's the issue with this? So then again, go back to the definition. Think about it. A multiple should be divisible by all these three numbers. And obviously, if I take 2 cube, then it won't be divisible by 80, right? Because 80 has 2 to the power 4. So I'll be able to cancel this out, but I won't be able to cancel this out. So I won't get an integer. Okay, so this is again the conceptual understanding that you should have. As far as process of solving the question is concerned, you just need to remember that you need to prime factorize it, and after that consider each prime number and their respective highest power. That's all. So I would take 2, 3, 5, take the highest power, multiply it, get my LCM. Okay, is this clear, guys? I'm bringing up the poll. Please let me know if this is clear or not. Okay, good. It's clear. Good. Now, let's come to the second part, which is the greatest common divisor. Now, greatest common divisor, divisors are what? These are factors, right? And I'm looking for the greatest factor. Okay. Again, let's take the same example. Step 1 in this case also is prime factorization. So let's get done with this. It's just exactly the same thing. Go back to the definition. What did I say? Factor obviously is a number which completely divides all the given numbers. So when I used to say 2 is a factor of 6, what I meant was 6 is completely divisible by 2, right? So when I'm looking for a divisor, greatest divisor, which divides all three of them. So I need something which divides all three. So if I want a divisor which divides all three, I need to ensure that a number that I'm choosing should be present in all three of them. For example, let me give you an example. Like say 80 has 5 in it, right? Now, can I say 80 is a factor of all three of them? Or is 80 is 5 a divisor of all three of them? It's not, right? Because 5 would divide 80. So I can say 5 is a divisor or factor of 80, but 5 doesn't divide 36, 5 doesn't divide 24. So obviously, if I want a common divisor, keyword is common, it has to be present in all three of them. That's the main thing. So as far as step 2 is concerned, it's very important for you to understand that you need a common prime factor. Okay, so in this case, the only common number, prime number, is 2. Okay, so just take that common prime number. Okay, now ask yourself the next question. Should I take the highest power or the lowest power? Those of you who went with the word greatest and thought, let me take the greatest power, you are again making a mistake. Think about it. This number, if I'm saying 8 is the greatest common divisor or a factor, this should completely divide all three of them. Okay. 8 would divide 24, not a problem because it has 2 cube in it. But will 8 divide this 36? It won't, right? Because you just have 4 in the numerator, so we won't be able to cancel it completely. That is why in case of the greatest common divisor, you always take the smallest common power. So this is 2, because this ensures that the number 4 would divide all these 3 numbers. So that is why the concept is take the common prime factor and the lowest power. Okay, so I'm reiterating it. Keep in mind, in case of lowest common multiple, the word is lowest, but we take the highest power. It's just the opposite. And highest power, and we consider all common prime. That's the main key thing, all common prime. In fact, I should say all prime without repetition. That would be a better way of saying it. I need to consider all prime without repetition. Okay. In case of GCD, though the word is greatest, we take the smallest. We take the smallest power, and we just consider the only the common prime number. If you remember this, at least questions which are based on numbers, you should be very easily be able to solve this completely. Okay, so once again, very quickly, please let me know if this is clear or not. If this is clear, then we can, start solving questions. Okay, great. I can see it's clear to everyone. Perfect, guys. Those of you who want to know more about, factors, multiples, and divisors, and total factors, because I went through it very briefly, you can, try a free trial account. Create a free trial account on at gmatquiz.com. Okay, those of you who haven't used GMATQuiz yet, you can just create a free trial account, and the prime numbers video lesson is available for free. Okay, so you can go through this primes video lesson where we have explained very elaborately the concept of factors and divisors. We have even explained elaborately the concept of total factors, even factors, and all factors. So you can just go and go through it once to if you want to solidify your understanding. Okay, with this, guys, let's start off with the first question. Now, let me explain the process. I'll give you a question, and I'll give you about 2 minutes to solve that question. Okay, and I'll open a poll. You need to mark the answer in the poll. And I want to emphasize on that. I do not want you to put your answer on the chat box at all. If you put it, I'm going to delete it. Okay, I don't want anyone to see the answers. Once I end the poll, then I would ask you certain questions. What kind of trap you fell in, or what kind of conceptual gap you have, and then we'll discuss the solution along with the question. Okay, and this obviously will help you solidify your understanding too. So I hope this part is clear. You need to mark your answers in the poll, and I would give you about 2.5 minutes for each question. Again, a lot will depend on the difficulty level also, but I'll keep that in mind. So I hope you can see the first question on your screen, and let me start the poll. So you have the poll in front of you. You should be able to see it. You have the question, and I'll give you 2 minutes to solve this one. Okay, guys, you have 30 seconds more. most of you so far have got it correct, which is good. Okay, last 15 seconds. And then I'm going to end the poll. Okay, ending the poll now. Those of you who haven't responded, please do so quickly. It's totally okay even if you get it incorrect. That's totally fine. But you should definitely give it a shot. Okay. So 76% of you think the answer should be B. How many of you found this question difficult? Or how many of you, for example, were not sure what to use? Is this the question of LCM? Is it the question of GCD? Or what formula should we frame? How many of you had that kind of an issue? Okay, guys, please respond. I want you to respond. That's totally fine. They told you I'm not interested with you. It's totally okay if you don't get it correct. That's totally fine. But if you found it difficult, please let me know. Okay, Shritya says she found it difficult. For some of you, found it easy. Difficulty level of this question is close to 600. This was an easy question to start off with. Okay. Got it right, but wasn't sure. Okay, Neha says got it right, but wasn't sure it was LCM or GCD. Okay, now that is why I asked you whether it was clear, to you what you need to use or not. Now, whenever you're given the question stem, there'll always be some keyword or the other that can help you understand what you need to use, whether you should use LCM or whether you should use GCD. Now, in this question, if you notice carefully, the word that is given here is divisor. Okay, now they're saying if the integer n is a divisor of 72 and 90. If divisor confuses you, you can use the word, replace it with factor also. Okay, what did we discuss? We already told you that I've already told you that divisor or a factor is a number that would completely divide the given number. So if n is a divisor of 72, then n would completely divide 72. And if n is a divisor of 90, it would completely divide 90. Okay, now there are two numbers given to you. The word divisor is given. Now, the moment you see the word divisor, it should be a trigger for you that, hey, let me first of all find out the greatest common divisor. Okay, so factor divisor should be the trigger or the key point that you should focus on to understand what you need to use, LCM or GCD. Okay, so what I'm going to do is, I've already told you the process of finding the GCD. What we do is, we take 72 and we'll prime factorize it. Now, this is basically 8 times 9, so we can write it as 2 cube times 3 square. Okay, and 90 is basically 2 to the power 1, 3 square times 5 to the power 1. I'm writing it directly. I hope all of you were able to at least prime factorize it. Now, how do we find out the GCD? I've already told you it should be a divisor, so it should be present in both the numbers. So we can you can say that the divisor or the GCD is going to be, we should have 2 and 3 both in them. Okay, now it should divide both of them. So obviously greatest means I'll have to take the opposite one. I just told you that's the best way to remember it. So you can take it this way and say that the GCD is 18. Okay, now in this case, thankfully this constraint was given. Okay, for a moment, let's forget about this constraint. Okay, let's think in this way. Notice that the question stem does not mention the word greatest here. Okay, if the word greatest common divisor would have been mentioned, then your answer would have been 18. You would have marked on without doing any further analysis. Okay. In this case, the answer though is 18, but there is a further analysis that you should definitely do. I'll tell you why. Since the greatest common divisor is not given, what you have found is the greatest common divisor. Now, there's another concept that you should keep in mind. The factors of the greatest common divisor, okay, are also divisors of the given number. Now, this might seem confusing, so I'll give an example to help you explain this. Think in this way: if 72 is divisible by 18, okay, then obviously whatever the factors of 18 are, and we have already told you factors are numbers which are lower or equal to, so the factor of 18 could be 9, 2, 3. These are the numbers, right? So if 72 is divisible by 18, then obviously 72 would be divisible by 9 also, which is a factor of 18. 72 would also be divisible by 3. It will also be divisible by 2, right? It would also be divisible by 6. So what you can say is that if you're just looking for factors, if you're just looking for divisors, normal divisors, then the process of finding all the divisors is, first of all, step 1 is to find the GCD. Okay, once you found the GCD, then what you can do is you can find all the factors of 18. Now, I've already taught you the formula, but I want to show you manually also a bit so that you can visualize it in a better way. Okay, I think these are the only factors. We cannot go any further. So you can say that n, the n which is a divisor, n can be 1, 2, 3, 6, 9, or 18, any of these values. Okay, n can take any of these values. So if this constraint would not have been given to you, the answer would have been cannot be determined. You would have said, hey, I cannot find out a unique value of n because n can take any of these values. Okay. However, we are given a constraint that n lies between n and 30. 9 and 30. So if it is greater than 9, less than 30, then the only possible value is 18 and nothing else, which is coincidentally the GCD. That is why you got the answer. So those of you who did not do this processing, you would have still ended up marking 18 as the answer. But keep in mind that this is the logic. If for some reason, if I would have given you something like this, if say 7 greater than n greater than 30, if we would have given you this constraint, then the value of n could have been 9 also, the value of n could have been 18 also, and in that case also your answer would have ended up being option E. Okay, is this part clear? I'll pause here. If you have any question here, please feel free to ask. Okay, so understand that the question was easy. This is one trap which I did not put in the question. Otherwise, most of you might have ended up marking the answer as B. However, the answer would have been E in this case. So this was the first question, so I deliberately made sure that I did not complicate it a lot. Okay, so keep in mind that. So I hope this is clear. If just divisor is given, what is your step? Step 1 is find GCD. Step 2 is find all the factors. Okay, and then if a constraint is given, like if a range is given, then check which one falls within n falls within which range, and then accordingly choose the correct answer option. Also keep in mind that you can get an alternate question in this case. You could also be given a question like this. A variation of this could be, instead of giving this, they might give you the question stem like this. The integer n is a divisor of 72 as well as 90. How many values of n are possible? Okay, you could be given a question like this. Okay, where they are asking you the total number of values. In this case, how many values are there? 1, 2, 3, 4, 5, 6. So your answer in this case would be 6 values of n are possible. Now, remember that you don't have to find it out. I was showing it to you. What did I tell you? That all the factors of 18 would be is a possible value of n, right? So now I've already taught you the total factor formula, right? You can use that. 18 can be written as, we already know 18 can be written as like this. So what I'll do is I'll find out the total factor. I'll take 1, I'll add 1 to it. I'll take this, I'll add 1 to it, and I'll get my total factors as 6. And I can say that the total possible values of n are 6. Okay, so if they ask you what is the value of n, then you need to actually find out the values of n. If they ask you how many values of n are possible, then find the GCD and then find the total factor. That's the process of solving such questions. Okay. Okay, Abhishek is asking, is there a faster way to determine prime factors of 2, 3 numbers? Uh, I'm not sure I understand your question, Abhishek. Do you mean, are you talking about prime factorization? Then unfortunately, no, there's no, faster way as such. You need to split it. In some cases, it's very easy to understand, like 72 is 8 times 9. In some cases, you'll have to keep on splitting to get the prime factorization done. Okay. So, within Nathan, if the question would have the word multiple, okay, in the question stem, so you would know that if the word multiple is given, then you would have to use LCM only. Abhishek, keep in mind that they would not give you very huge numbers, okay? They would not unnecessarily give you 15, 20 or don't expect those to happen. It would, at the max, would be a 3-digit number, and those should be fairly easy to work with. Okay. Okay, guys, I'm moving on to the next question. I don't see any more questions here. So here's the next question, guys, and let me bring up the poll. Here's the poll, guys. Another 30 seconds, everyone. Last 10 seconds. Those of you who haven't responded, please do so quickly. Okay, ending the poll. So, guys, those of you wondering when to use, multiple, this is one of the questions. I hope now you can see that in this case, the word multiple is given, right? By the way, I've ended the poll. 30% of you think the answer should be D, and 50% of you, 51% of you, in fact, think the answer should be A. Frankly, these are the two options I had expected most of you to mark. I had seen I can see some of you have marked B, C, and E also, but B, C, and E are definitely not the correct answer. Let's see out of A and D which one is correct. Okay. Now, as I told you, translation works. If now the definition or knowing the definition is very important, as I was discussing in the start of the webinar. So, if you see a question like this, that is n a multiple of 80, then that basically means n is equal to n 80 times k. Okay, so if n is a multiple of 80, you should be able to write it like this. If if the translation is still tricky for you, you could have thought in this way, that if n is a multiple of 80, then n can be 80, 160, 240, basically 80 times 2, 80 times 1, 80 times 3, and so on and so forth. So basically it should be some value and should basically take these values. Okay, that is what I'm trying to find out. With this understanding, we'll move on to the statement one, because we don't have anything else with us. Here it is given that n is a multiple, again the keyword is multiple, of 5 and 16. Note once again that this question doesn't say that n is the lowest common multiple. It just says n is a multiple. However, it's not a problem. In this case also, whenever you see n is a multiple of two numbers, simply find out the lowest common multiple first. Okay, so 5 is already 5 to the power 1. You cannot do anything with it. 16 is basically 2 to the power 4. So if I want to find, the LCM is simply going to be 5 to the power 1. I'll take both the prime numbers and their respective powers. So the LCM turns out to be 16 times 5, which is 80. Okay. Now, if n is a multiple of these two, the lowest possible value of n is 80. But n can be some higher multiple also, and thus we can write n as 80 times k, which is exactly what we are looking for. So we can say that this statement is sufficient. I'll pause here again and reiterate what I have done. I found out the lowest common multiple. Keep in mind, this is the smallest. If I want to find the next highest, I would simply do 80 times 2. If I want to find out the next highest, I'll do 80 times 3, and so on and so forth. Now, if n is a multiple of these two, then it is guaranteed that the minimum value of n has to be 80. It can be more than that also. It can be 160, 240, but will definitely have 80 in it. So I can surely say that n is a multiple of 80. I'll pause here. Please let me know if this part is clear or not. Then I would move on to the next statement. Yes, Naveen, there's a small trap in this one. If this is clear, please mark yes. I hope you can appreciate that if we are able to translate it properly, if we're able to visualize it into the number line, the question, solving this question becomes pretty easy. Okay, I can see it's clear to everyone, which is good. So let's move on to the second statement. Once again, we'll follow the same methodology. Okay, we can again see n is a multiple of 8 and 10. Now we are not told lowest common multiple, but we will still find out that, because that helps me understand what is the smallest value possible. Now 8 is 2 cube and 10 is 2 to the power 1 times 5 to the power 1. So my LCM is going to be, I'll take both the prime numbers and the highest powers. Now my LCM comes out to be 40. So what I can say is that the minimum value of n is 40. It can be higher also, because I've just mentioned the word multiple, not the lowest common multiple. So here also, if I have to express it, I'll express n as 40 times some integer. So let me write it as q. Now, is n a multiple of 80? Well, I cannot be sure. Like for example, if n is 40, then my answer would be no, that n is not a multiple of 80. Remember, if it's a multiple, then it has to be either equal or more. It cannot be less. Okay, so if n turns out to be 40, your answer would be no. However, if the value of q, say for example, turns out to be 2 or 3 or 4, then n could be 80, 160, 240, and in such cases your answer would be yes. But since you cannot be sure whether n is 40 or 80 or some higher multiple, you cannot answer the question using this statement. That's why this would be not sufficient, and the answer in this case would be option A. Okay, so I hope it's clear when to use divisors, how to use the greatest common divisor and find out, the possible values of n, and how to use the lowest common multiple and find out the possible values of other multiples. Once again, I'll bring up this poll. Please let me know if this is clear or not. If there are any doubts, please feel free to ask in the chat box. V, can you tell me which part to repeat? What part was not clear? Uh, it would be great if you can point out. Okay, JP is asking, how did you know LCM so quick? Which part? Where did I did not find out the LCM quickly. I did each and every step. If you notice, I found 8 is equal to 2 cube. I found 10, 2 times 1, 5 times 1. LCM would be the prime numbers. As I told you, I'll take the each prime number and I would take the respective powers. Now 8 times 5, 2 cube is 8. 8 times 5 would definitely be 40. 16 times 5 is also 80, which is something I remember. So for me, 16 times 5 was quick. If you don't remember it, you can obviously solve and get the answer like this. Okay, this is closer to 650 sort of because of the trap that was set in the statement 2. Okay, I can see it's clear to everyone. So I'm ending the poll now and I am moving on to the next question. Okay, I have this one. Why not 2 to the power 4? Where are you saying why not 2 to the power 4? JP, we don't have 2 to the power 4 here. We have the highest power is 3 and 1. So I cannot take 2 to the power 4 in this case. Okay, I hope it's clear to you. Okay, let me bring up the poll for this question. Yes, JP, LCM always takes the highest power. I just saw your question. It will always take the highest power. GCT would take the lowest power. LCM would take the highest. Okay, guys, last 30 seconds. Last 10 seconds, and I'm going to end the poll. Harshita, I'm increasing the difficulty level in each question. So this is now closer to 650 to 700 level. The reason the difficulty level in this one is higher is because of the variables. In fact, let me just end the poll and then start the discussion. Okay, a very interesting result in front of me. Once again, there's a confusion between A and D, and these are the two, most frequently marked answers. I did expect a slightly higher percentage of E, by the way, but that's okay. Just to be very clear, B, C, E, all these three are not correct. The answer has to be either A or D in this case. These are the kind of questions where having a very good conceptual clarity or knowing how to set up the equation, the ones that I was showing you at the starting of the webinar, is very, very, very important. So if I read this question, the stem is pretty simple, right? A and B are integers, fine. They are both greater than 1, which is good. So positive integers greater than 1. That's the only inference. The question is also fairly simple. Is a factor of b? Now, this is where you need to translate it really well. If a is a factor of b, factor or divisor of b, then that means b would be completely divisible by a. Think about it. B is here, factors lie this side. So if a is a factor of b, then b upon a must be an integer. Okay. Or you can translate it and also write b must be equal to a times some integer. Whatever be the case, but you should be able to translate it in this way. So if I get b by a is equal to some integer, well and good, I have my answer. If I'm not able to get it, or I'm not sure whether b by a would be an integer or not, I would say that statement is not sufficient. That's the main crux out here. Okay. Now see how translating this can make our life very easy. Let's look at statement 1. Statement 1 is a square plus a minus b equal to 0, right? Now I can write it like this. I can take, I need the form of b by a. Keep this in mind. So can I take b to the other side and write b is equal to a square plus a? Okay, I need b by a. So can I divide all sides by a and end up getting b upon a is a plus 1? Okay, now can anyone tell me what is a plus 1? Is it an integer or is it a non-integer? A plus 1? If there's any doubt, obviously always go back to the question stem. Ideally, it should be written on your statement, on your piece of paper, but you can go back and look and see that a and b are integers. So obviously, if a is an integer, a plus 1 also will be an integer. So from here, I am directly getting my answer that b by a is an integer, and hence I can infer that a is definitely a factor of b, and thus this statement is sufficient. See how easy it is once we know what we are trying to find out. Looks complicated, a lot of expressions, and you might not know what to do. But I hope you can appreciate it now that this is like super easy once you set up the equation. The same logic can be applied here also, by the way. Okay. Now, a square plus a is equal to, I'm taking kb to the other side. Okay. Now I need b by a. I'm flipping and writing it, by the way. It's easier for me to work with it. So I'm writing it like this. Okay. So it's the same thing. Now, I need b by a, so obviously you can divide by a first, or you can divide both sides by ak. You can do that also. You would get b by a is equal to a upon k plus 1 upon k. And if you want, you can write it as a plus 1 upon k, like this. Now, this is where this is like a red flag. You should ask yourself, okay, I know a plus 1 is an integer. Well and good. I know k is an integer because it's given to me k is an integer. So all good. But can I be sure that integer by integer would definitely give me an integer? Okay, you should ask yourself this question, because at the end of the day, I want b by as an integer. And if you take cases, you'll be able to understand it. 6 by 3, just giving a random example, you would end up getting an integer. So integer by integer could give you an integer, but the integer by integer might not also be an integer. And you cannot be sure, 100% sure, what is a plus 1 by k. You cannot be sure whether it's an integer or whether it's a fraction. And since we cannot be sure whether it's an integer or a fraction, we would end up saying that this statement is not sufficient. Okay, because we cannot be sure whether b by a would give me an integer or not. Hence, the correct answer in this case again would be option A. Okay. Please let me know if this is clear or not. Those of you who especially marked D as the answer, or those of you who chose something else apart from A, I hope now you've understood how the differentiation will come into picture and how you need to use that, focus on that a lot while simplifying your expression. If you do that, you'd be able to answer these questions very quickly, very easily. Okay, great. I can see it's clear to everyone, which is good. Perfect, guys. I'm really happy that it's clear. Okay, I can see a question. Yes, as I told you, this is a question level that falls between 650 to 700. Okay. Now, let's move on to, in fact, in the interest of time, because you have done a lot of multiples question, let's try out a question on factors, guys. So this is a question based on total factors. This is slightly on the difficult side. So take your time. I'll give you about 3 minutes to do this question. Okay, another 1 minute, guys. Okay, last 30 seconds. Okay, I'm going to end the poll now. So those of you who haven't responded, if you want to mark any answer, please do so. Okay, tell me, what do you think of this question? Were you able to translate what the question was exactly asking you? Or did you have trouble translating this also? By the way, the answer options are pretty, the result is pretty, scattered, I would say. It seems that most of you weren't very sure what to do here. 30% of you think it's B, 26% A, 23% D. So it's all over the place, I would say. Okay. Harshita says difficult, Saurav says troubled. Okay, yeah. So this is slightly tricky because of two reasons, I would say. One is because of the language, where especially when you see the words like exactly 6 positive factors greater than 1. That's one of the issues. Okay. And the second problem is, so far, whatever I've shown you or discussed with you now in those questions, we were always given a number and we had to find the total factors, which was very easy for us. Now in this case, it's totally opposite. We have been given how many factors does a number have, and we are trying to find out, how many positive factors number would n have. Okay, and you're given n cube 3 and b. So in short, you are not given an exact number. You are given simply a variable to work with. Now, before I solve this question, okay, before I solve this question, I would take up, just the slide to explain a few things to you. Once I think if that part is clear, solving this question would not be that difficult. Okay, so let's spend some time on the concept that I want to talk about. Now, for your reference, I'm writing here. If you remember, uh, uh, to find out the total factors, what we do is we prime factorize the number like this. Okay, and then we find the total factors as taking the powers. Keep in mind we multiply the powers, blah blah blah, like this. Okay, and it's not necessary that they will definitely have three prime numbers or more than three prime. It depends on the question. So for example, if my n, say for example, I'll take in fact let me take three cases. If my n is say 5, okay, then 5 is just 5 to the power 1, right? So it's just p1 to, so I can, kind of say it's just like p1 to the power a, right? So in this case, my total factor would just be a plus 1 because I just have 1 prime. So I would write it as 1 plus 1, 2, right? So that this is one kind of case where you just have one prime number with a power and you just add that power, add 1 to that power and get the total factors. This could be one case. Case 2 could be something like this, like n could be say 4. Okay, or let me take n, let me take n as say 6. Okay, now 6 is 2 to the power 1 times 3 to the power 1. We have two prime numbers, two powers. So in this case, you would have 1 plus 1, 1 plus 1. So basically a plus 1 times b plus 1. So you'd end up with 4. So what I'm trying to say here is that the total factor, to get the total factor, it might be a standalone a plus 1. It could be a product of two numbers. It could be a product of 3 also. If I end up, say, for example, if n is something like this, then in that case, I would have to add this also and then get my answer. Okay. Now, in difficult questions, most of the questions which are difficult, you would be given this number. Okay, like this is 12, I think. Yeah, 12. You would be given this number. And then you would be asked about n. They would ask you, hey, tell me what's the possible value of n. Those kind of questions would be given. Okay, so what I would want to do is I want to discuss two cases with you. And once you understand those two cases, believe me, solving these questions would become very easy. Case 1 is a case where your total factors is, say, a prime number. Let's say, for example, a case like this. Let's say 5 to the power 4. Okay. Now total factors would be how much? 4 plus 1 equal to 5, right? So I can say total factor is a prime 5, right? Now let's take a case. Let's say if you are given that the total factors of a particular number is say 7, it's given to you. Okay. Now they are giving you this number and you want to find out how can I write n? What would be the power of a, b, c, d? I need to figure this out. Now 7 is a prime number which cannot be broken down. I cannot break it down any further. I can write 7 as 7 times 1, but 1 doesn't make any sense. Okay, so whenever you have a prime number, total factors as prime number, you should be able to infer that this basically comes just from a plus 1. There's nothing else. There's no b plus 1, c plus 1, d plus 1, nothing is there. This is simply a plus 1 is equal to 7 or a is equal to 6. And the number n can be written as p1 to the power 6. Is this part clear or not? I'll pause here. If you have any questions, feel free to ask. If this is clear, please mark yes. Simple concept. If the total factors is prime, then obviously I cannot break it down. If I cannot break it down any further, then I would simply take a plus 1 is equal to that prime number and find my number. Okay, as simple. Okay, I can see if you're saying no. If there's any question, please feel free to ask. Vedanath, you need to tell me what part is not clear. If you say, please repeat this once, I would not know what to repeat because I've been speaking for 5-7 minutes. So you have to be more specific. Is this which part is not clear? I'm simply saying total factors. How do you find total factors? You express it in the form of a, prime factorize it. You take the power, you add 1 to it, and you get your total factors. Now, if your total factors turns out to be a prime number, then a prime number cannot be broken down into multiple parts. So you simply take that prime number and equate it to one of the, you basically infer that n is of the form p1 to the power a, if you want to understand in this way. It just has one prime number with one power, that's all. That's the example that I gave you now. Okay. Let's take an example of n is equal to, say, 11 to the power 6. Now, 11 to the power 6, what would be the total factor of this? The total factor would be simply 6 plus 1. See, I'm not adding anything else here. When I say adding, I mean I'm not multiplying. There's no b plus 1, c plus 1 here. It's just a plus 1. You take a, you multiply it by 1. So in short, what I'm trying to say is that if the total factors is a prime number, let's say 2, 3, 5, 7, then you can infer that your number is of the form p1 to the power a. And how do you find out a? You just take these total factors, equate it to a plus 1, and you get the power of a, get the value of a. Okay. So Vedanthan, Ashmita, Ashitima, I hope it's clear now. If there are any questions, please feel free to ask. Okay. This is case 1. Case 2 could be where your total factors could be a composite number, like for example 4, 6, 8, blah 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 blah, or 9, something like this. Now, good part is that in GMAT they won't ask you for the total factors. They won't give you total factors of composite numbers beyond 6. So either you'll get 4 or you'll get 6. Okay. Now, when I say total factors is 4, what do I mean by that? Total factors is 4. There are two cases out here. For in case 2 also can be divided into two particular cases. Case 2. So one of the cases could be if that a plus 1 is itself equal to 4, or a is equal to 3, which means my n is of the form p1 to the power 3. Okay. And if you want example, you can take the example of when n is equal to 8. If you take n is equal to 8, it's written as 2 cube. And this basically gives you 3 plus 1, which is equal to 4. Okay. So you can get your total factors like this. The other case out here could be that the total factor, you got 4. Since a composite number, it can be broken down also, right? It can be broken down as 2 times 2. So if you are breaking it down into two parts, you will have to take two numbers also. Product of two numbers is 2 times 2, and infer that a is equal to 1 and b is equal to 1. Only when a is equal to 1 and b is equal to 1 would you get 2 times 2. And that would mean, since you're taking a and b, that means the number n is of the form p1 to the power a, p2 to the power b. And since a and b are 1, these would be 1. So in case of a composite number, you break it down into two parts. One part is where you just assume that the number itself, the total factor is basically a plus 1, or your number is of the form n is equal to p1 cube. The other case is where you break it down into two parts. And if you want the example of the second case, this example could be 6, which is 2 to the power 1 times 3 to the power 1. And in this case, your total factor, if you remember, was actually 4. 1 plus 1 times 1 plus 1. I'll summarize it briefly because this is like these kind of questions can come in various form in PS also. So if your total factors, if given to you is a prime number, just infer it cannot be broken down any further. So the only way to write it is a plus 1 is equal to that particular prime number. And since you're taking just a, you're just taking a, b, c don't exist. The numbers of the form p1 to the power a. Simple. Okay. If it is a composite number, then there could be two cases. Either it is simply a plus 1 equal to 4, or if that, since a composite number, it can be broken down into two parts. If it can be broken down into two parts, you take two of the products out here and then equate it to that two parts and then find out the value of a and b. If there are any questions, please feel free to ask. If this is clear, then I would move on to the question and then solve it using this concept. Please mark yes if this is clear. Okay, good. I can see it's clear to everyone, which is good. So now let's move on to the question. Before using this, before showing the solution, let's translate it here only. What does this statement mean? N is a positive integer. Simple. Okay. I've been told n cube has exactly 6 positive factors greater than 1. Okay. Exactly 6 positive factors greater than 1. So if I ask you how many factors does n cube have, what would be your answer? How many factors does n cube have? Is it 6 or is it something else? N cube has exactly 6 positive factors greater than 1. So how many factors does n cube have? Naveen, correct. Asitima, you're also correct. Diego, you're correct. 7, right? Because 1 also needs to be included. Just to give you an example, if again, I know I'm taking a simpler example, but I think it will help. Now, in this case, in case of 6, I can say now 6 has exactly 3 positive factors greater than 1. So that means the total number of factors would be 3 plus 1, 4, because I need to include 1 also, because 1 is also a factor of 6. So in this case, if they're telling me that n cube has exactly 6 positive factors greater than 1, then I would say the total factors of n cube is 7. Okay. And we'll solve it, don't worry. But I just want to make this clear now only. So if this is clear, those of you for whom it wasn't clear, can you tell me what would I say in the second statement? How many factors does 3n have? If it says 3 positive factors greater than 1, how many factors does it have? Will it be 3 or will it be 4? 4, right? So I'll say 3n has 4 factors. Okay. So I hope this part is clear, because I'm going to just use this and get my answer very quickly. So if I'm solving this question, first inference is that n cube has 7 factors. Now remember, I told you that if the total number of factors is 7, then remember what did I tell you? You simply take a plus 1 is equal to 7, and you would say a is equal to 6. And you would say that n cube, the number, can basically be written as p1 to the power 6. Is this part clear? Let me bring up the yes and no poll. The total number of factors is 7. So it cannot be broken down any further. So I'll take a plus 1 is equal to 7. I would get a is equal to 6, which would mean that n cube is p1 to the power 6. Okay, those of you are saying, I can see a small percentage of you saying no. Can you let me know what's the issue? I'll wait for another 10 seconds. If I don't see any question in the chat box, I'll move on. Okay, I don't see any questions, which is fine. Okay. Okay, so n cube is p1 to the power 6. So now understand I need the total number of positive factors of n. So what I'm going to do is I'm going to break this down, and I'm going to take the case of, because I need n, I'll take the cube root of this, and I would say that this n is basically p1 square. Okay, I hope this part is clear, that n is p1 square. Now, if n is p1 square, then can I find out the total number of factors? Anyone? If n is p1 square, then what would be the total number of factors? Very good, guys. So see, this is perfectly easy. See, didn't take us a lot of time. The total factors would simply be 2 plus 1, which is equal to 3. So we have our answer. Now, let's come to statement 2. Okay, let me just check the chat. Let me see if there are no questions. Okay, I don't see any questions in the chat. Very good. So we can. I don't think. Okay, I can see two more thing. N3 part, NQ part is not clear. Vaishaki, please understand this, that the number, when I say n, let me go back to the previous slide. When I say n, okay, this capital N could be anything. It could be n cube, it could be x square, it could be any number. N basically denotes a number, okay? So n could be 8, which is nothing but 2 cube. Are you getting my point? So we don't know what it is. So in general, you need to understand that this n cube is a number. It's basically capital N. Think in this way. 7 factors. So capital N can be written as P1 cube. Now replace this capital N by the number, actual number that you have. Okay. I hope it's clear now. This part is clear. Okay. I don't see any more questions. So let's move on to the second statement. Okay. Now second statement is 3n has exactly 4 factors. Okay. Now remember I told you if you have 4 factors, then you'll have to make cases. Case 1 could be that a plus 1, this is as is 4. Then that means a is equal to 3. And 3 times n can be written as p1 to the power 3. Okay. Now think about it and tell me what would be n in this case. Understand that I'll give you a small hint that 3 is itself a prime number. On the right hand side also you have a prime number. Can we infer what is this prime number? What is this p1? Anyone? Ashidima, in this case, it would make sense because it's just p1 to the power 6, okay? Just one prime number. So you were lucky to get the answer. There could be multiple prime numbers in that case, like p1, p2, p3. If nq would have been p1 to the power something, then p2 to the power something, p2 to the power something, then the answer would have changed. In this case, it was easy because there was just one. So you were cubing it, cube rooting it, and you were getting the answer in one shot. Okay, so not always correct. I hope that answers your query, Sitiman. Let's look at JP is asking, how did you know that n is? I did the cube root here. Okay, so when you do cube root, what basically means it, you're dividing the power both sides by 3. Okay, so you end up with n to the power 1 is equal to p1 square. Okay, I hope that answers your query. Okay, all of you are saying 3 for my question. I think the one that I asked. So yes, P1 would be 3. So this would be 3. Has to be 3 because a left hand side is equal to right hand side. So I can say n is equal to 3 square. If I get n is equal to 3 square, then the total factors in this case would be 3. But keep in mind, this is just case 1. There could be a case 2 also. Case 2 would be where, as I told you, a plus 1 times b plus 1 is equal to 2 times 2, which would give you a is equal to 1 and b is equal to 1. So you would end up saying 3 times n is p1 to the power 1 times p2 to the power 1. Okay, now you already have on the left hand side, you have p1 to the power 1. On the and you can compare the prime numbers on the left hand side and right hand side. So you can say 3 to the power 1 is p1 to the power 1 and n to the power 1 is basically p2 to the power 1. Okay, so n is basically p2 to the power 1. Now in this case, understand that your total factors is going to be 1 plus 1, which is equal to 2. So you are getting contradictory answers. In one place you're getting 3, in the second case you're getting 2. Since you're getting two contradictory answers, that is why you would end up saying that statement 2 is not sufficient. Okay, I hope it's clear, guys. I hope you've understood that why this is not sufficient. If you want an example, I can give you one example is already here. N is equal to 3 square. The other example in this case, obviously, if n is 2 to the power 1. In this case also, this condition would be satisfied. 3n would exactly have 4 factors, and you would end up getting the total number of factors as 2. So the correct answer in this case is going to be option A. Please let me know if there's any doubt. Please feel free to ask. Giorgio, that's just one of the cases that you have written. 3n has 4 primes, just minus 1 primes. So there are 3 primes. There's just one case. Okay. There would be another case which I've shown. I hope that part is clear. Naveen, I'll summarize it. Don't worry. Yes, Giorgio, the correct answer in this case is option A. JP, again, keep in mind that's what I explained, right? I just told you that 4 is a composite number. What do we do in composite numbers? In case of composite numbers, we break it down into two cases. One case is where I take it as is. In the second case, I break it down into two parts. I'm just following the methodology, nothing else. I know my total factors is 4. This is a composite number. So I'm taking one case and I'm writing it as a plus 1. And if you're thinking, why, how did I know that this is p1 to the power a? Keep in mind, if I'm just taking a plus 1, that means I'm assuming that n doesn't have anything else apart from p1 to the power a. If I'm taking a plus 1, b plus 1, then what I'm assuming is that n is of the form p1 to the power a, p2 to the power b. Okay. I hope that answers your query. Pratik, case 1, which one? By the way, I just reiterated it now. So Pratik, please let me know if it's clear or not. I simply assume that the total factor 4 is basically of this form. So a plus 1 will be equal to 4. So a would be equal to 3. So I can say n is equal to p1 cube. Now my n in this case is actually 3 times n, 3 times small n. Okay. So understand, right hand side is a prime number cube. It's like p1 times p1 times p1. Left hand side is 3 times n. And this is also a prime number. 3 is a prime number. So if I want my left hand side to be equal to the right hand side, I can assume now that I can infer, not assume, I can infer that p1 has to be 3. There's no other option. And if p1 is 3, then n obviously is p1 square, which is 3 square. That is how I inferred that n is equal to 3 square. Okay. Please let me know if this is clear. I am I'm showing the poll again. Please mark yes if this is clear. Naveen, that would take a lot of time. I would want to do a few more questions. 6 would also be the same. It's not that tough. I'll give you a very small hint out here very quickly so that you're able to do it on your own later on. I'm writing it here. See, if the total factors is 6, then case 1 would be a plus 1 is equal to 6. And case 2 would be, 6 can be broken down 2 times 3. So we'll write a plus 1 times b plus 1 is 2 times 3. Try it out. After this, it's pretty easy. You don't have to do anything. A is 1, B is 2. That's all you have to do. So I hope after this you'll be able to do it. But these are the two cases, guys. If prime number case and composite case is clear, you can solve any total factors questions pretty easily. Okay. Okay, in the interest of time, guys, I'm moving on to the next question. There's one more question which I would like to discuss, which is based on LCM GCD. But before that, again, I told you that if you're interested in solving these kind of questions that I'm discussing, especially the ones where I've used the total factors concept, if you want to try it out, once again, these is there in Prime's video lesson, which I've already told you is there in the free trial. So if you want to try out the free trial, you should definitely try it out. And you would be able to solve a few more questions like these. And there's a detailed video solution also, so you can go to the video solution once again and see if there's any part of the solution. If anything that is not clear here, those video solutions should definitely help you out. Okay, So definitely do watch the free trial. A very small announcement, guys. If you're liking these webinars and if you want, attend more like these, then we are starting our online GMAT crash course on the 26th of June. These webinars are more structured in nature, because what we do is we conduct a very elaborate each sessions. So as you can see, there are total 25 sessions, in which there are 12 sessions on quant, 12 sessions on verbal, one session on strategy. And what we do is, in each and every quant session, we take up one particular unit. And when I say a unit, I mean which would compose of, say, only primes and even odd and one or two topics. And we discuss questions elaborately on that particular topic itself. So if you are, if you're planning to take the exam in R1, or if you want to, if you're liking these webinars, if you want to gain more in-depth knowledge on how to solve questions, especially people who struggle a bit on figuring out what's the right methodology to solve the question, these webinars are definitely for you all. So if you want to register for these webinars, I would recommend that you uh, l- um, go go and look at our crash course. Once I am sharing the link, you can have a look, and if you're interested, then you can get in touch with us. Oops, just one sec. I've shared the wrong link, guys. Just one sec. Let me share the correct link. This is the link of the crash course. So those of you who are liking this webinar, definitely look at this. And okay, so that's about the brief announcement. Now let's look at the LCM GCD concept. As I told you, I'll be discussing one small concept before solving any question in LCM GCD. So let's do that very quickly. So far, I'm sure you must have understood that if you are given a number, you can very easily find out the least common multiple and the greatest common divisor of that number. But most of the difficult questions would give you the LCM, and they would expect you to find NMN. Okay, they would expect you to find the numbers. Now, can anyone tell me, if someone tells me that the LCM of N and M is 6, what are the possible values of N and M? Anyone? 2361, 1661, 2332. 612. Okay, Diego says infinite. No, they're not infinite. They are limited. But to find them out, you need to understand that you need to first of all break down 6 into two parts: 2 to the power 1, 3 to the power 1. Okay, and then infer that n and m, either both could have these or none of them could have these. Okay, so what I mean by that is, if both of them have it, then it could be 6 6. Okay, it's quite possible that 6 is present in only one of them and it's not present in the next one. It could be quite the opposite also. There could be a case where you have 2 3, 3 2, 2 6, 3 6. All these cases are possible. Now GMAT would obviously will not ask you to find out all of these cases, just to be clear, but in you might get a certain portion of this question or the application of this understanding, that if I have 2 to the power 1 times, if the LCM of two numbers is 2 to the power 1, 3 to the power 1, then it is quite possible that each number might have both these prime numbers. Okay, that is very important for you to understand, especially this kind of a case. That if the LCM is 6, then it's quite possible then both of them could be 6. It's quite possible that 2 times 3 could be present in just one of the numbers, and it's quite possible that one of the numbers just have one of the prime numbers, the other has all of it. So this understanding should be there. Okay, don't worry that they will not ask you to find out all these cases, but I hope the understanding is clear. Similarly, if I tell you that the GCD of n and m is 6, can you tell me what are the values of n and m? Okay, Ishma says 612. Anyone else? That's a correct answer. That's one of the possibilities. Neha says 6 6, correct. Now, this is a place where you can definitely say that there are infinite cases possible. It could be anything. You don't have to. You cannot figure out what could be the possible value of n and m. Now, what you need to remember is how to translate it. Understand, when I say that the GCD of NMN is 6, then that means both of them would definitely have 6. And by your answers, I'm sure that you have understood that fact that both of them has 6. But they could have something else also in it. I'm not sure what that something else is. Okay. So N could say, for example, could be 30, which is 6 times 5. And M could be, say, just 6. So K1 would be 1, right? N could be 30, and N could be, say, example, let's say 6 times 7. Okay. Important thing for you to understand is that whenever you are given a expression like this, you should be able to translate it in this form. That's very important. And you should be able to remember also that K1 and K2 are positive numbers which are co-prime. Now, those of you who don't know what co-prime is, it basically means that the GCD of K1, K2 should be 1. They should not have anything in common. Nothing in common. Now, if you're wondering why, think about it. If I have 6 times, say, 14, if I take this 6 times 14 and 6 times 1, now this is my K1, this is my K2. Now, if they have something in common, then your GCD would change. Your GCD then would become 12. Because now, not 12, my bad, the GCD would become 42. Because now they would have 6 and 7 both common in them. So it's very important for you to understand that K1, K2, they do not have any factor in any common factor. Okay. Please let me know if this part is clear or not. I'll bring up the yes and no poll. Please mark yes if this is clear. Okay, I can see it's clear to everyone. Okay, guys, by the way, I forgot to share one more link, so I'm sharing it very quickly with you. Those of you who are interested in the crash course, or those of you who are interested in, working with us with GMAT Quiz, if you want to know how we can help you out, you can book a session with us. I've shared the calendar link with you. I'm even broadcasting it. And you can just set up a one-on-one call with us, and we can let you know how GMAT Quiz can be helpful for in your GMAT prep. Okay. So if you have any questions regarding our course or our crash course or our private tutoring courses, feel free to set up a call with us. Okay. Okay, guys. So if this part is clear, guys, let's do one question, just one question, and let's take this one. This is like the most difficult one, but this would help you understand whatever we have discussed just now. And let me bring up the poll. Okay, I'll give you 1 more minute. Last 15 seconds. Okay, I'm ending the poll now. Okay, guys, tell me, how did you find this question? Was this difficult, easy? Okay, Naveen says difficult. 41% of you ended up marking the answer as C. I don't think C is the correct answer, but let's just check. Gaurav says easy, okay. JP says no clue, difficult, very difficult, difficult. Okay. Okay, let me discuss this, and after my discussion, tell me whether you find this difficult or not. Okay. Okay, Anubhav says P into Q is GCD into LCM. Okay, Anubhav, the question was whether it was difficult or easy. Okay, guys, let's discuss how to solve this question. So what's given to us is that the least common multiple of two positive integers is P and Q. Of P and Q is 630. So what you can do is you can simply prime factorize it. So the 630 can be written as 2 to the power 1 times 5 to the power 1 times, I think, 3 square times 7 to the power 1, right? And the GCD of P and Q is 18, okay, which can be written as, in fact, let me do one thing. Let me write it like this, okay. Now, I just told you that if with the LCM, finding out all the possible cases is pretty difficult, right? Because there could be multiple cases. But when it comes to the GCD portion, we know that if the GCD of the two numbers is 18, then we can write this as 2 1 time P is equal to 2 to the power 1 times 3 square, and Q is equal to times K1, and 2 to the power 1 times 3 square times K2, where I'll clearly mention that K1 and K2 are coprime. Okay, and I'm showing you this method using, mathematically, algebraically. There are inference where you can also draw an inference and get the answer. But let's try this out. Let's try the algebraic way of doing the question. Just one small observation, one small inference that you should be able to draw is that since GCD is 2 to the power 1 times 3 square, obviously you're sure that 2 to the power 1 times 3 square is present in both of them. So now the only thing that is left for you to place is 5 to the power 1 times 7 to the power 1. Okay. Now let's just say you don't know the formula. You don't know the formula LCM into GCD is P into Q. You are not aware of it. You can logically also think and say that obviously 5 to the power 1 cannot be present in both of them. It cannot be present in P and Q both. It has to be either in P or it has to be in either Q. Same goes for 7 to the power 1. It has to be in either P, it has to be in either Q. So on the basis of that, you can create your cases, right? You can say that P could be 2 to the power 1 times 3 square times, let's say I take a case where I assume both of them are present in one of the numbers only, like this. This could be one of the cases where K2 would be just simply 1. K2 would be 1 and K1 is 5 to the power 1 times 7 to the power 1. Keep in mind that you can reverse this also. Now, if you in the exam time, if you want to write it down, you can write it down. If you want to keep a mental note of it, that is also fine. But you could have a case like this. Case 3 could be that these are individually present in one or the other. Like for example, 2 to the power 1, 3 square, 5 to the power 1 is present in this, and 7 to the power 1 is present in this. And we can even reverse this case. Notice after doing this, do a quick check, because in the exam you might be in a hurry, you might make a mistake. Just do a quick check and check, hey, is the GCD 2 to the power 1 times 3 square in all of the cases? Yes, the GCD here is 2 to the power 1 times 3 square. The GCD here is 2 to the power 1 times 3 square, 2 to the power 1 times 3 square, 2 to the power 1 times 3 square. And obviously LCM would turn out to be correct because I have included all the prime numbers in these cases. Now, please let me know if this part is clear or not, because if this is clear, after that, solving these statements are pretty easy. I'm again reiterating the process. Keep in mind, if you are given the GCD of two numbers is something, you simply write them as like I've written 18 times K1, 18 times K2. After that, you can draw inferences based on whatever is left in the LCM and decide where you need to put them. Okay. Okay, I can see it's clear to everyone, which is good. Somebody said no. What is it? Please let me know what is not clear. Okay, if something is not clear, please let me know. I'll move on to jump to these statements. I don't see any question in the chat box yet. So I'll move ahead. Okay, first statement is P is a multiple of 35. Now, this is a pretty easy statement. It simply tells you that P needs to have 5 to the power 1 times 7 to the power 1 in it. Multiple means P can, or if you want to use, the definition of multiple, you could say P is 35 times something, some integer. Okay, I've already used K1, K2, so let me use K3 for example. So you can get P definitely needs to have 35 in it. So if it needs to have 35 in it, in which case do I have 35 in P? This is the only case, right? This is the only case where P has both 3 and 5 in it. Okay, I need to find P minus Q. I can easily find out the value of P minus Q using case 1. For statement 1, case 2, case 3, and case 4 are not valid. I have only one case, one unique case, which gives me my correct answer. So this statement would be sufficient. Okay, I hope this part is clear. If you have any questions, please let me know. If not, please mark yes. Then I'll do the second, solve the second statement quickly. Okay, can see it's clear. Very good, guys. Very good. Now see, when I say that the GCD of QN 35 is 1, can anyone tell me what's the meaning of this? If the GCD of two numbers is 1, what is the meaning of this? I just talked about it now. Okay, Vaidyanathan is asking, doesn't case 2 also have 35? Yes, it does have 35, but statement 1 says P should be a multiple of 35. They are not saying Q should be a multiple, okay? Okay, any other question? Anubhav is saying, what if P is 70? Anubhav, how can P be 70? P needs to have 18 in it. That is the reason I always ask everyone to write it in this way, so that they don't write these cases of 70. 70 is not possible because I need to have 9 in it, Anubhav. So the P can be 79. These are not possible. If the GCD is 18, then that means both of them minimum will be 18. Okay. So Sudeep, Anubhav, I hope it's clear. Now coming to my question, Hishma says Q is 18. Q does not have 5 and 7. Co-prime, no common factors, co-primes. Very good, guys. That is the meaning of this. This clearly tells me Q does not have 3 and 5. Both of them, it does not have both of them. So, in out of these four cases, in which case Q doesn't have both of them? This is the only case, right? This is the only case in which Q does not have both of them. In any of the remaining cases, the GCD of Q and 35 won't be 1. It would change. In this case, if I take the GCD of Q and 35, it would turn out to be 35, right? In this case, the GCD of Q and 35 would turn out to be 7 because Q has a 7 in it. I'm just showing this to you so that you understand why am I just considering case 1 and I'm not considering these cases. Okay, so notice that even this statement is sufficient. In fact, the correct answer in this case is option D. Okay, is this clear, guys? Please let me know if you have any doubts. Yes, GP. Remember, I just told you at the start of the webinar that divisors, factors, they are the same thing. These two words are used interchangeably. Okay. Any other questions? Okay, Pratik says, please explain statement 1 again, please. Pratik, you need to tell me what is not clear. P is a multiple of 35. Now, what did I tell you about multiple? If P is a multiple of 35, P would be somewhere higher, P would be somewhere here. So P has to be 35 times something. So the inference that you need to draw is that P must have 7 and 5 in it. So if P must have 7 and 5 in it, only case 1 is there where P has both 7 and 5 in it. In case 2, in case 3, in case 4, it does not have 7 and 5 both in it. So I'll discard these three cases, and I would say that the only case possible is case 1. Okay, Pratik, I hope this is clear. Naveen, yes, see, understand that since we are doing this for the first time, it might seem difficult. It might seem there's a lot of hard work to do. But if you break down the process, think about it. What are we doing? The question would always give you LCM GCD. Break it down. If the GCD is given, then you write down the two variables in the form of that GCD. The way I have written it is 18 times K1, 18 times K2. Okay, once you have that, then try and think what K1 and K2, what values K1 and K2 can take. That part would take some time. That might take you 1 minute or 1.5 minutes, but the remaining portion should be done very quickly. And notice once you have all the cases, I did not even have to solve anything in statement 1 and statement 2. I was just inferring, nothing else. Okay. Ritika, this is 700 plus. Okay, some people are asking me to explain statement 2 again. Shrutia, you said C. I'm not sure why are you saying C. The answer would be D. If there's any confusion, please feel free to ask. Please ask questions. Okay, very quickly, guys. In statement 2, the GCD of, think about it. What did I tell you about GCD? In GCD, we take 35 is what? 7 to the power 1, 5 to the power 1, right? And I'm saying that the GCD of this is 1. When can the GCD be 1? The GCD can be 1 only when Q does not have 7 and 5 in it, right? If Q has a 7 in it, let's say if Q is 14. This is a random example, okay? I know Q is a multiple of 18, but just giving you an example. Let's say if I am trying to find out the GCD of 14 and 35. Now 14 has a 7 in it. If I have a 7 in it, my GCD would turn out to be 7. So the only case my GCD would not turn out to be 7, it would turn out to be 1 when there's nothing common between the two numbers. Which means the inference that you need to draw is Q does not have a 7, Q does not have a 5 in it, which means Q does not have a 35 in it. Now, only in case 1, we have a case where Q does not have a 7 or a 5 in it. Okay, in all the remaining 3 cases, Q does have a 7 and a 5 in it. So obviously the GCD in these 3 cases won't be 1, it would be something else. That is why we are discarding case 2, case 3, case 4 and saying case 1 is the only solution which is possible. I hope it's clear, everyone. Yes, Ritika, that's totally fine. P into Q is equal to LCM into GCD is also fine. In fact, you would end up with the same result, a simplified result, but not everybody knows it. So I was focusing on a methodology where even if you don't know it, you can logically infer. Now, JP is asking, how did you come up quickly with case 1, 2, 3, and 4? I came up with this case because, as I told you, if you remember this, which I was discussing out here, I use this concept. So if I know that 3 is one of the part that is left, let's say for example, this 2, 3 can be present in any of these numbers. So when I saw 5 and 7 were left over, 2 to the power 1 times 3 square is already there. I needed to place it in either P or Q. Now, how can I do that? I can do that only by taking case one could be if I take all this 35 and give it to one of the numbers, okay, which I did in this case. I gave it to P first and then I gave it to Q because these are the only two options. The other case possible is if I give one of them to P, the other one to Q, and then reverse it. So I would get my case 3 and case 4. Okay. So you can use this. Those of you who know the LCM into GCD formula, you can also use this concept to find out the values of K1 and K2. So there's a formula which is LCM times GCD is the product of two numbers. This is the standard formula that you can remember. It's universally accepted. So what is my LCM? My LCM here is 2 to the power 1 times 3 square times 5 to the power 1 times 7 to the power 1. What is your GCD? GCD is 18. I'm writing it directly, okay, because there's a lack of space. What is P? P is 18K1. And what is Q? Q is 18K2. Now notice this 18 would get cancelled out. This 18 and this 18 would get cancelled out. So on the right hand side, you're left with K1 times K2. On the left hand side, you're left with 5 times 5 to the power 1 times 7 to the power 1. So your case 1 could be for example, your case one of the cases would be K1 is 5, K2 is 7, and you can reverse the process. Once you do that, you would get your case 3 and case 4. Okay. The other possibility is if you multiply it and get 35 and write it as 35 times 1. Now you can say K1 is 35, K2 is 1, which I have got here, and then you can reverse it. So if you want, you can use this process also. This is also totally fine. I use either of them, but the end result is going to be the same. Okay, so I'm giving the yes and poll once again, one final time. Please let me know if this is clear or not. But at a high level, remember when LCM GCD is given, break down, prime factorize, write down the two variables in the form of GCD, and then move ahead and find out the values of the variable K1 and K2. Either you can infer it or you can use the LCM GCD is equal to P times Q to get the answer. Both of these are totally fine, totally valid methods to solve the question. Okay. Okay, guys, with this, we have come to the end of this webinar. So the last question which I wanted to discuss with you. I hope this was the session helped you. It was and you gained a lot from this. If there are any questions regarding, in general regarding quant or GMAT Quiz or GMAT, please feel free to ask. Okay. Thanks a lot, Naveen. Thanks, Giorgio. Thanks, Neha. JP, as I told you, the recording would be shared on the YouTube channel. So I would request you to, I'm sharing the YouTube link once again. You can use that link and subscribe to it. Once we upload it, you'll be able to see it there. Okay. Thanks, Ritika. Thanks, Anshul. Thanks, Rajavi. Rajavi, we don't share a PDF of these webinars, unfortunately. So if you want to see these questions again, you would have to look at the video recording. Okay. Yes, the video recording would be available. It would be available on our YouTube channel. I'm broadcasting the YouTube link. I hope all of you are able to see it. Just copy it, paste it on your, and just subscribe to it. You should be able to you'll get a notification once we upload the video. Okay. Okay, Ritika has a question. I have a question regarding the careless mistakes I make. How can I save myself from falling the trap? Because I talked about this. I've talked about this a number of times in my webinars. And the first thing which I would say is, if you want to improve, then you have to categorize your mistake in a better way. Careless mistakes, silly mistakes are, if you categorize your mistakes in these ways, it would be very difficult to know where you need to improve. Okay. So the first and the foremost thing, Ritika, that you need to do is, figure out What do you mean by careless mistake? Is it that you don't read the question properly? Is it that you make a calculation mistake? Is it that you know end up not taking all the possible cases? Do you solve questions very quickly in the interest of time, saving time? What is the main reason behind this careless mistake? Once you understand that, then only you will be able to fix it by putting in a conscious effort on it. So for example, if you say that, hey, I end up not reading the question properly, the solution is very simple. You need to start reading questions properly. Take a little bit more time and read it properly. Okay. Let's say if you make calculation mistakes, then try again, deep dive and figure out what kind of calculation mistakes. Is it that you not good with some kind of multiplication, addition? What is it? If those are the kind of mistakes are there, then you need to work on that. Immediately it's not reading the question stem, then the solution is simple. Because spend time on the question stem. As simple as that. Before starting a question, say to yourself that I'll read the question stem properly. I'll jot down each and every information in the paper before solving the question. You have to put in effort to it. Like for understand this, that in such cases we cannot. There's no magic pill for this that I'll give you and you'll improve. uh, you have to follow the methodology like we follow it. So if you look at some of our boosters video lessons, if you go and see, and if you look at any of our webinars, also free webinars, you'll notice that most of the times I jot down all the information that is given. I'd make sure that small things like remember the question that we were doing where I had said that A and B are integers and A is greater than 1, B is greater than 1. I take care of these small things. I make a note of it saying that both are positive integers, both are greater than 1. I'll write it down. They might seem trivial to you or most of the students, but I know that sometimes these kind of things are ignored by most of the students. GMAT examiners who create the questions know that, and they'll set up a trap based on that. I've made those mistakes. So what I do is I make a conscious effort of reading it properly. Now, I know this might not sound a very foolproof solution, but unfortunately, this is the only solution. So whatever question that you do from now on, make sure that you spend more time on the question stem. Okay, so when you want to create an error log, ideally, as I told you, you should not just categorize correct, incorrect. So there are certain standard things which you should definitely capture. Okay, so for example, you should capture information like whether you got the question correct or not, what was the difficulty level, how much time did you take in that question. These are pretty standard information. That what topic does that belong to. These are standard information that you should always jot down. Okay, that's definitely there. But apart from that, what you need to do is you need to also create a column where you write down exactly why did you make a mistake, if you made any, or why did you take a lot of time if you took time. So and that column should be a standard column. So you should fill it with standard of responses like made a calculation mistake, fell for a trap, did not read the question properly, or forgot to apply have forgotten the particular concept, did incomplete analysis. These are certain tags that you need to create for yourself, and there should be another column just next to the tag of a comment column, where if you want to elaborate more on the mistake that you have made, do so. Then after every 2 weeks, 15 days, you should go to that error log, look at the kind of mistakes that you're making, create a pivot, try and see what is the most common type of mistakes that you're making, and then put effort on trying to minimize that as much as possible. But you have to categorize it really well. So I hope it's clear. Apart from the standard error log that is present in most of the places, you'll find one on GMAT Club also. Add this also. Add two more columns in them: a comment column and a standard column with standard tags, like the one that I talked about. In fact, just to let you know, we are since we are talking about tags and error log, since we understand that people do have a habit of, you know. Not creating a proper error log and categorizing it at silly mistakes. Most of our questions on GMAT Quiz now in the next, I think, a week or so would have these tags on each and every question. So any student who would want to put a tag on that question, they'll be able to do it, and then later on be able to see also what is the most frequent kind of mistake they are making. So we are going to get that feature soon. In fact, it's ready. We are just in the process of deploying it. But to answer your question, this is the way you need to do it. Once you start categorizing it properly, you'll be able to minimize your mistake. Okay. Okay, I don't see any more questions. I hope that was helpful, Ritika. So I'm going to end the session now. If you have any questions, guys, the email ID and the phone number is there on on the screen. Make a note of it, and feel free to write to us, and we'll be glad to help you out. Okay. Okay, guys. Okay, then I'm ending the session. Have a great day. Bye.